Hello everyone, this is Wei. Welcome to my channel. Today I would like to share with you about my second programming learning project. I made a Tetris game using pygame. First, let's take a look for my final result. Let's go! There are three different windows in my Tetris game. Window 1, Start window. It contains welcome messages. Window 2 is the game playing window. It is the main platform of the game. On the left, it is the game board, where tetraminos fall down and stack. On the right, it has blocks for next tetramino preview and scoreboards, as well as the game logo. Window 3 is the game over window. It displays a scoreboard on the left and asks if the player wants to start again. And I want my three windows to run like this. First, we have window 1. The window 1 will display the welcome message, as well as another message that tells the player that if we click the enter key, it will go into window 2. The window 2 is the main platform for our game. If the game over, it will go into window 3. The window 3 will show the scoreboard, and it also have a button called play again. If the player click that, it will go back to window 2. And this is the workflow of my three windows. In order to achieve this workflow, I designed a pseudocode block that contains the organization of these three windows. In general, my pseudocode block contains two while loops. This is my first loop. It contains the content of window 2 and window 3. Within this while loop, there's another nested while loop. And for the nested while loop, it contains the animation inside the window 2 and also the condition to define whether the game is over or not. And the code for the window 1 is written before the first while loop starts. Now let's have an overview of the pseudocode block. This is the second while loop. It is nested inside the first while loop. And it contains the animation of the window 2 as well as the condition that determine whether the game is over or not. And here is the first while loop. It contains all the information for window 2 and window 3. And for the code for the window 1, it is written before the first while loop starts. Now with this big picture in mind, I'm going to go into the detail of every single window. So first, let's take a look for window 1. Here, I drew a simple version of the window 1 on the whiteboard. As we can see, the window 1 is pretty simple. It has a platform where in the middle it contains two messages. So basically, for setting up the code of the window 1, what I really need is to set up several parameters, such as the window width, window height, and also the text information, including the font, color, the position of the text. So here are the basic parameters that I set up for the window 1, including the window properties, the text information, as well as other things such as the sound. And that's the introduction for window 1. Now let's move on to window 2. Here I drew a simple version of the window 2 on my whiteboard. As we can see, the window 2 has been separated into several different blocks. On the left-hand side, it is the game board. On the right top corner, it is the preview box which will show the next tetramino. And on the right middle, it is the box for the score. Last, on the right bottom corner, we can see there's a game logo. Here, I'm going to specifically focus on the game board. In general, I set up the whole game board into a matrix. For example, here I drew a game board. It has 4 rows and 4 columns. There's already 4 cells that has been occupied by the tetramino square. So if I'm going to transfer it into a matrix, it will look like this. The cells that has already been occupied by the square, I'm going to set up it into 1. So here it is 1, 1, and here this would be 0, 0. This is 0, 0 here. This is 1, 1 over here. And for the top 2 rows, all of them will be 0. So now for the game board, I have a corresponding matrix for that. In total, I have 7 different types of the tetramino in my game. I'm going to list them all over here on the whiteboard. These are the 7 different tetraminos in my game. Every single unit is composed of 4 squares. For every unit, I also set up a matrix for them. For the first one, it will be a 4x4 matrix. This is 3x3. 3x3 for the yellow one, 2x2, 3x3, 3x3, 3x3. Here, I'm going to use the pink one as an example to show you how would be the small matrix look like for the tetramino. The 3x3 matrix would be look like this, And similarly as the game board matrix, every cell that has already been occupied is set up to 1. No square occupation will be 0. So this is 1, 1, 1 in the middle, all the rest are 0. So in general, I have the whole game board as a large matrix and the falling down tetramino as the small matrix. So the game can be interpreted as the small matrix falling down inside a large matrix. And with that, I can set up the general rules for my game running. The first rule that I want to consider for the coding of the game running is called bottoming, which basically is to consider where does the small tetramino located inside the large tetramino, and then decide whether to stop or whether to continue falling down. There's 2 conditions that we need to generate the new tetramino. Number 1 is when the small tetramino touch the bottom. Number 2 is the tetramino that stack onto the tetramino that already existed on the game board. The second game rule that I want to consider is how do we get the score? So for getting the score, if in the game board, the whole row has been occupied by the squares of the tetramino, this row will be removed and then we get 1 point. Number 3 is game over. When the stacking of the tetramino exceed the top border, the game over. Here are the 3 main game rules that I consider during the coding. And next, I'm going to talk about tetramino rotation, where it's the coding case that I found very interesting to discuss. As we discussed before, there are in total 7 different types of the tetramino in my game. And if we consider the rotation, it in total would be 19 different types. So the simplest way to show them is to list all the positions of the squares of every single tetramino out, which I think the code will be very redundant. And then I did some research and finally I set up a function which only needs to use 1 line of the code that can achieve this rotation function. This is the line of the code that I used for rotation. I'm going to break it down. First, the unit here represents the structure of my tetramino. For example, if I have the pink tetramino, the pink one is a T-shape. So what would be its matrix look like? It would look like this. And in Python, it would be written into a large list that contains 3 lists. Each list represents 1 row of the matrix. So it will look like this. And the zip function in the Python, which is to aggregate the elements on the same index into a tuple. If we zip this matrix, it will take all the elements on the index 0, which would be 0, 0, 1 over here. The second would be 0, 1, 1. So this is the output after the zip. Now I use a for loop to take every single tuple 1 by 1. If I take the first tuple, which is 0, 0, 1, and first I transfer it into a list. And then with this symbol, I'm going to return the output reversely. Now the first tuple will look like this. It will be a list and then written from the backwards. So it's going to be 1, 0, 0. And similar applications to the second and third tuple. So this is the final output after this line of the code. And let's compare this with the initial input. What do we see? If I'm going to circle all the ones which represent the tetramino squares in the pink T-shape, it will look like this. And the output, the ones are all located here. As you can see, this pink tetramino have a clockwise rotation for 90 degrees. So we finished the rotation just with 1 line of the code. How beautiful it is. Now finally, let's move on to window 3. Here I drew a simple version of the window 3 on the whiteboard. For the window 3, it used the background of the window 2. The only difference is it's going to generate a scoreboard in the middle of the game board. It will show the scores as well as a button called Play Again. When the player clicks it, it's going to go back and restart the game. Alright, that is the end of the story. Comparing with my first programming learning project, which is to use pygame to make a snake game, this one contains a little more coding complexity. It is a little challenging for me at the beginning, but after I figured them out, I really enjoy the whole process. For the source code, I put them on the GitHub. I attach a link for that in the info box below. You should be able to run the program if you install the pygame properly, so I also attach a link for the pygame installation as well. Hope you enjoyed the video and see you next time.